Hey guys, Mrs. Sands here. So I'm gonna try and keep this short. What I had planned for today was a PowerPoint that gives you the definitions of these transformations that we're doing. But you know what? I'm just gonna attach the PowerPoint to the Google Classroom, and if you feel like you need to watch it, you may, but I'm just going to give you the notes and try and talk you through what transformations really are. So if you could just follow along with me, and then you'll see instead of doing the homework in the workbook, we're actually going to be doing Delta Math as homework. So we'll do this do now together. It really is just review of graphing. When it's in y equals mx plus b, I could see that the slope is 2, or we like to write it as a fraction, 2 over 1, and the y-intercept is negative 4. So we start at the y-intercept, and we go up 2 to the right 1. It's important to put arrows at the ends of the line. It's important to label the line. Now they want us to graph y equals 2x plus 4, so the slope again is 2 over 1, and the y-intercept is 4. Without even graphing, I know that these lines will be parallel because they have the same slope. They slant the same way. I'm just starting at 4 now. And again, arrows and labels are important. So how are the graphs related? Well, they have the same slope, therefore they're parallel. Right? They have a different y-intercept. So like I said, instead of doing the PowerPoint presentation, I'm just going to give you the notes that we would get from the presentation, and you can watch it on your own if you want to. A translation really is when a figure changes location. It slides from one spot to another. When it changes location, or when I say it slides from one spot to another, it's moving right, left, up, or down. It slides, I'm going to use the word slides, right, left, up, or down. So an example, if I were to draw a triangle right here, if I slid it to the right and down, it would land right here. And the triangles are always similar. I mean always congruent. Sorry about that. I tried to draw it exactly the same, but without a ruler and a protractor and all that stuff, it's hard to make it perfect. These two figures really are congruent. And like I said, it could slide right or left, it could go up or down, and it would actually tell you how much to slide it and in which direction. We're going to skip like the real world part of it for now. A reflection, well, we see our reflection every day in our mirror. Imagine if you were wearing a shirt with writing on it. When you look at your reflection in a mirror, aren't the letters backwards? So a reflection is a reverse image. It really like flips over a line. It's a shape that flips over a line. So when you're looking in the mirror, your line that your image flips over is the actual mirror. And I'll give you an example of that. So if I had triangle here, and I have to give you a line of reflection. I'm going to give you a vertical line to reflect over. So that's my line of reflection. Remember, it's a reverse image, so the triangle would be more like this. And again, I'm drawing it the best I can. I know it's not perfect. I'll make it a little bigger. Maybe that would make it easier for me. So it's a reverse image. It flipped over that line. A real world situation would be like a mirror. A rotation, well, to rotate means to turn. So it is when a figure turns or spins. We're going to be dealing with a certain number of degrees when we turn it. You really can turn a figure any number of degrees. You'll see when we get to rotations in this workbook, we're going to be dealing with just 90 degrees, 180 degrees, 270 degrees, and 360. 360 degrees, the figure just turns right back on top of itself. But really, it is a turn. So if I had a figure here, if I turned it just 90 degrees in this direction, it would now be a figure laying down. I don't really like my picture there. I'm going to try that again. So that is the best picture I could draw of a rotation. Rotations create congruent figures. And I'm going to go back up to reflection. It also creates congruent figures. And rotations, we see it like when we're on a bicycle, the tires of our bicycle, tires rotate, wheels rotate, right? There's quite a few things in the world that rotate. And dilations, we have already done a dilation. This is the one transformation that creates similar figures. Remember we said dilations, the figure gets bigger or smaller. And we've already talked about it. The way it gets bigger or smaller is by multiplying by a scale factor. So if I were to draw a picture of it, I could start with a large triangle, and then it becomes a smaller triangle. Dilations, we had said the pupils of our eyes. They get larger and smaller. So the new figure, we've actually talked about this when we did our dilations. The new figure is called the image. The original figure is called the pre-image. And the way that we label it, remember if the pre-image point is A, then the image point we call A prime. So that's some review. So this first picture is a picture of a translation. The letter F stayed facing the same way. It didn't get bigger, it didn't get smaller, it didn't flip, it didn't turn. All it did was slide. It kind of went up to the right. But in the second picture, this is a rotation because the letter F turned. In the third picture, this is a dilation because it got bigger or smaller. And in the last picture this is a reflection because it's a reverse image and you can see the line that it reflected over. There you go. That's our transformations. To transform means to change, and there are 4 ways we can change it. We can reflect it, we can dilate it, we can rotate it, and we can translate it. So you do not have to do this problem set for homework. I want you to work on the delta math, but I'm just going to do this first row with you just to make sure we understand our transformations. So if this is our beginning polygon, and it became that, it looks like a reverse image, so this is a reflection. Then from here to here, it looks like it turned, so it's a rotation. From here to here, it's facing the exact same way, it just slid over. It's a translation. From here to here, it's a rotation. From here to here, it's a reverse image, so it's a reflection. And again, from here to here, all it did was slide over, so it's a translation. There weren't any dilations in this first row. Everything stayed the same size. Everything had congruent figures. Dilations make similar figures. So when you go to Delta Math, please remember that there is a video here to watch if you're unsure of what to do. I could look through like a problem with you right here as you're watching just to make sure you know what you need to do. It says that figure E is the result of a transformation on figure D. So it started as figure D and it became figure E. So which transformation would accomplish this? I notice it definitely looks like it turned. Okay, so it's got to be a rotation. Now, how many degrees did it turn? Well, it didn't turn completely upside down. So it did just go 90 degrees. There is kind of a trick when you're doing it on a coordinate plane. If a figure just moves over one quadrant, it is 90 degrees. So if it goes around this way, that's counterclockwise. Going to the right, that would be clockwise. So if it started at D, became E, it went counterclockwise 90 degrees. Oh, let's look at another kind of problem. That one's also a rotation. Let me find a different one. That one is also a rotation. This one. This is definitely a reverse image. It definitely looks like it flipped over the x-axis. So a reflection over the x-axis. That's a reflection of the x-axis. Here, they're facing the same exact way. So this is just a translation. Figure K is the result of a transformation on figure J. So it slid over to the left and up. It's going to want to know exactly how much did it slide. So it's either the first choice or the third choice. Pick a point. Look where my mouse is. And I'm going to count 1, 2, 3, 4 to the left and 1 up until I get to the corresponding point. 4 left and 1 up. So it must be that choice. We haven't done a dilation. I don't think dilations are going to be in this. Rigid motions, see this word rigid motions, actually means that we're just going to be doing translations, rotations, and reflections. So finish these problems and I will see you tomorrow. This is your homework, so I'm going to make sure that this gets done and I'll be checking to make sure you took the notes. See you soon. Bye.